So students, after deriving the capacitance for a parallel plate capacitor with a dielectric slab, today we will solve the capacitance of a parallel plate capacitor when in between parallel plates there is a conducting slab. Here in between parallel plate capacitor we introduce a conducting slab, then we find out the capacitance, what will be the capacitance for this parallel plate capacitor. So once again, welcome to your favorite channel TKG physics classes, and according to my time, good night to all of you. Okay, let's begin the class. So first of all, you draw the diagram. Suppose this is a positive plate and the positive plate charge is represented by plus q, and this is a negative plate and the charge of negative plate that is represented by minus q, and this is the plate separation is represented by d, and suppose the each plate area is a. Now in this case, when there is no dielectric or conducting slab, that is there is vacuum, what is the capacitance? All of you know the expression of capacitance. Suppose this capacitance expression is represented by C naught and the expression is epsilon naught A by D. This is the capacitance when there is a vacuum between the plates, right? And in this case, you know the expression of electric field. The electric field between the plates, in that side electric field 0, in that side electric field 0, and between two plates the electric field is this one, directed along positive to negative direction, and you know the expression sigma by 2 epsilon naught plus sigma by 2 epsilon naught. So final expression is sigma by epsilon naught. Okay, write it down. Suppose this electric field is represented by E naught. So the expression of E naught becomes sigma by epsilon naught. In the place of sigma, you can write Q by epsilon naught A. So what is sigma? Sigma is called the surface charge density. So this is the electric field when there is a medium, that is vacuum. Now here we introduce a conducting slab of thickness T between the parallel plates. Okay, let's introduce. Suppose there is a conducting slab of thickness T, this thickness T, and this is introduced between these two plates. What will happen? You know, in conductor there is large number of free electrons. So here, as there is a positive plate and there is a large number of free electrons, these free electrons easily store at that side. Negative electrons, negative charge is stored at the left side of this conducting slab. And how much number of electrons store? That is exactly opposite to this amount of charge. Suppose here charge is plus q, so here the amount of charge which is stored, that is minus q. Similarly, the opposite side, that is the right side of this conducting slab, the charge stored, that is positive. And how much amount of charge? That is exactly opposite to the negative plate charge. So here the amount of charge stored, that is plus q. So here, due to induction, due to induction of charge, due to induced charge, due to polarization, a electric field developed which is directed positive to negative, and this electric field is represented by EP, electric field due to polarization, or you can call electric field due to induced charge, that is EI, you may call it EI. Okay. Now just check one thing, this EP, this induced electric field here exactly opposite to this amount of electric field, that is the initial electric field which is directed positive plate to negative plate. So here EP exactly equal to E naught. So what is the net electric field inside this conducting slab? You know the expression of net electric field. Net electric field expression E, that is equal to E naught minus EP. Now here EP is exactly equal to E naught. So if we write this expression E naught minus, in the place of EP you can write E naught, so this expression becomes 0. So the net electric field inside the conducting slab, that is 0, and this point is very important. This is the vital point for this derivation, that is the net electric field inside this conducting slab is 0. There is no electric field. That is why no electric field, because here the electric field due to polarization exactly similar, exactly equal to, exact magnitude value equal and exactly equal to E naught. So the net electric field, that is 0. Now same condition, you have to find out capacitance, that means Q by V. This is the formula, all of you know. So for finding capacitance, at first you have to find out the potential difference. So what is the formula for finding potential difference? That is the potential difference between these two plates is represented by V is equal to, you know the formula, this expression E is equal to minus dV by dr. So in this from this expression we can write V is equal to E into D, that is V equal to electric field into D represent the separation. Okay. Now what is potential difference here? That is V is equal to electric field is represented by E naught, this one. So in the place of E you can write E naught, and what is D? D is the separation, that means the region where the electric field E naught exists. Now check one thing, the thickness T in this region there is no electric field, that is E naught 0. So E naught present how much separation, how much distance? That is this left side and this right side separation. In between them in thickness T there is no electric field, E naught is 0. So E naught is present over a distance that is represented by this separation is D, this separation is T. So this portion and this portion becomes D minus of T, right? So this separation becomes D minus of T. Now just putting the value of E naught, you know the value of E naught, this one, that is Q by epsilon naught A divided into multiple of D by T. So this is the expression of V, potential difference between two capacitor plates. Now just use this formula, then capacitance C becomes Q by V, that is Q divided by Q by epsilon naught, and there is D minus T. So Q cancel out, epsilon naught A will be upper side epsilon naught A divided by D minus T. So this is the expression of capacitance for a parallel plate capacitor, expression of capacitance for a parallel plate capacitor when a conducting slab is placed between them. Conducting slab is introduced between them. So this is the general expression. Now express it in another way. Suppose we can write C is equal to epsilon naught A divided by D by T, D minus of T. Now you just write here epsilon naught A divided by T into D divided by D minus T. That means this D and D is cancel out. So expression becomes this one, epsilon naught A divided by D minus T. Now what is epsilon naught A by D? This one, epsilon naught A by D, that is C naught. So C naught multiple of D upon D by T. So this is the expression, this is the another expression. Okay, write it down here, that is C is equal to C naught D divided by D minus T. That means here we can express the capacitance with respect to in terms of C naught, that is the capacitance when there is a vacuum. That is, we can say C is how much times? C is D by D upon D divided by D minus T times with in terms in multiple of C naught. Here you can say C, this portion is smaller than with respect to D, so C greater than C naught. That means when we introduce a conducting slab between the capacitor plates, then the capacitance becomes larger than the capacitance of a parallel plate capacitor when there is a vacuum. That means in introducing a conducting slab, the capacitance increases. So what happened here? First of all, you have to think, you have to find out this portion, the electric field inside this conducting slab, and the conducting slab electric field is 0. This is the final point. Now you find out the potential difference, and then using this formula, just putting this value and simplify it, then the formula becomes this one. C equal to epsilon naught A divided by D minus T. Now you can express C with respect to these terms. Okay. So this is also an important theory for your board exam. Suppose you have to find out, there is a question, you have to find out dielectric constant. Dielectric constant for conductor or metal. For conductor or metal, you have to find out dielectric constant K. What will be the answer? You know, that is K is equal to E naught divided by E naught minus EP. That means the dielectric constant is defined as E naught divided by E. What is E naught? The initial electric field, original electric field. What is E naught minus EP? E naught minus EP, that means the net electric field. Where? Inside this region. Now, what is E naught minus EP? You know here EP exactly equal to E naught. So, this difference becomes 0. That is the inside the conductor electric field E results 0. So, the value of K becomes K equal to E naught divided by 0. So, something by 0, that means K becomes infinity. So, you can say the dielectric constant, the relative permittivity for a conducting slab, that is infinite. That means it decreases the electric field how much times? That is nearly is equal to 0. So, this is all about this class, students. If there is any problem, let me know. Okay. Till then, bye bye.